Hello everyone, my name is Parjang, a former senior lecturer at university and a current quantum education staff. Today I want to talk about AIMO exam, which is Australian Intermediate Mathematics Olympiad. And as the name says, it is for students in year 7 to 10. Now, the structure of AIMO consists of 4 topics: number theory, geometry, combinatorics, and algebra. And the whole exam has 10 questions. The first questions are worth less, usually 2 marks. And the last questions number 9 and 10, worth more, most of the times about 5 marks. And the last question number 10, has a bonus part, which gives you extra score. Now, AIMO is actually designed for exceptional students who show a very good talent in mathematics. But today, I want to show you that by studying these topics, by practicing these topics, you're gonna learn how to do very well in the AIMO. And to do this, I am going to cover the last 2 questions, which usually are the hardest questions in AIMO. So I'm going to cover question 9, which is 4 mark, and question number 10, which has 5 mark. And then you're going to learn and you're going to see that how easy it is to solve these questions. Okay, so we want to go over question number 9 of the previous AIMO exam at 2020. And question number 9 worth 5 marks. It's about an identity in combinatorics, and they have asked us to prove this is true. And we've been given that K is smaller than M and M is smaller than N. And it's obvious because of the factorial sign, all these numbers are integers. Now, the first thing that, in the first glance, what comes in mind is this is a little bit scary equation. We don't know what to do with this, but it's okay. A very good strategy, especially in these types of questions when you want to prove an inequality and your numbers are integers, is to just plug in some numbers. Change the question. Suppose this question was, is this inequality true? Now, if we want to prove that, we're going to assume some numbers for N, K, and M and see, is this really true? In doing this, we're going to get a very, very good insight about the structure of this inequality. So what I'm going to do, I'm going to plug N equals 10, M equals 7, and K equals 3, and see what happens. Okay, so what I did, I plugged N is 7, N 10, M 7, and K 3 in this equation. And then what I want to see is what happens. Okay, so this is the left-hand side, and this is the right-hand side of the inequality. Let's see what happens. As you see, 4, 3, 2, 1, 4, 3, 2, 1. They completely cancel each other out. I have the same similar structure on the right side. 7 times 6 up to 1 and 7 times 6 up to 1. So I completely cross them out. I know these cancel. So what I have to prove is just I have to show this is less than this. I'll write them again. I make it a little bit shorter, and then you see what to do. Okay, so I just write what's left. And again, we know this 7, 7, 10, and 10 cancel each other out. And the only thing that we have is 6 divided by 7 times 5 divided by 7 is smaller than 9 divided by 10, 8 divided by 10. So we have to show this. Now, the general form of this is if we have to find that. Is it true that a number, say x, divided by its next number, so x plus 1, is less than, so I want to compare 6 by 7 and 9 by 10, by another random number greater than 6. So what I have to have here is greater than x. Say y and then y plus. This is what I want to prove. And if I prove this, I know 6 divided by 7 is always less than 9 divided by 10. 5 divided by 7 is always less than 8 divided by 10, and my proof is complete. Okay, so the general thing I want to show is if I know x is smaller than y and a is positive, then is this really true that x minus a divided by x is smaller than y minus a divided by y? Cross multiply these two, and what you're going to get is xy minus ay is smaller than xy minus ax. These two cancel each other out. Rearrange this, you're going to get ax is smaller than ay. Again, cancel a, and then you come up with your assumption. So yeah, if x is y, which is what we had, we always know this is true. Okay, so what I've done is, now that we have proved that for a random number of, I think it was 7, 10, and 3, we just plug in m and n and then see what happens. Right now on numerator, I have m factorial. On denominator, I have this part, which is m to the power of k, n minus k factorial. Again, n to the power of k, n minus k factorial, and n factorial. Completely similar to what we did when we used numbers. We again know this part and this part cancel each other out. And this part and this part cancel each other out. And what's left, again, I'm going to cancel this and this and this and this. So what's left is I have to show m minus 1 divided by n, which is this part. The next one is m minus 2 divided by n. So times m minus 2 divided by m up to m minus k plus 1 divided by m is smaller than the same thing on left-hand side. So you have n minus 1 divided by n, n minus 2 divided by n, up to n minus k plus 1 divided by n. And that's actually what we proved by the example that I showed you. What we proved was x minus a divided by x is always less than y minus a divided by y. So m stands for x, n stands for y. Now we know m minus 1 divided by m is always less than n minus 1 divided by n. We know the same thing with the second term. We again know the same thing for the third term. So we have k terms here, k terms here. We know each of them. The first one is less than this. The second one is less than its corresponding second term. The third term is smaller than the corresponding third term. So the whole thing must be less than the right-hand side, and this completes our proof. Then I'll show you question number 10, which has 5 marks, but as I said, it has a bonus. It's on geometry, and we're going to cover that.